All right, kiddos, I am going to redo a few of these example problems from our notes. Originally, I taught this lesson using the TI-84 graphing calculator, but we do not all have access to that right now. What we do all have access to is Desmos. So I'm going to teach you how to do this in the Desmos calculator. And if I'm being honest, it's actually a little easier in the Desmos than it is in the TI-84. So here is example number 2. And what we need to do is find the X value with the largest residual. So I'm in Desmos over here. Let's go ahead and add a table. And I'm just going to type in my Y or X and Y values really quickly. Okay, 19, 13, 7, and 0. So I've typed in all my values. If I adjust my graph a little bit, you can see all 4 of these points. I can tell you that it does have a positive correlation. I don't know how strong it is. Maybe it's a moderate positive correlation. But let's find the actual line of best fit now. So you can click plus and do your f of x expression. Whoops, I actually want it to be under here. There we go. So I'm going to type y. Remember to have your keyboard open. So let me go ahead and show you. Click on the bottom left corner, open your keyboard, and I want you to click on ABC. So you can click the Y from here, or you can use your actual computer's keyboard to type the letter Y. But to do our subscripts, we need to use this A sub B button. Type 1, arrow over to the right. Remember that we need to use this little squiggly on the bottom of this. Okay, we cannot put an equal here. It won't work if we do that. We have to use the little squiggly. And then my M for my slope, my X, my subscript 1, arrow over to the right, plus B. Okay, and so what I'm seeing in blue now is my line of best fit as it goes through the points, okay? Look at my R squared right here, and I do see, right here, I do see, okay, that's a decently strong positive correlation. My slope is 1.3, and my y-intercept is at 0.58, okay? All right, now how do I find the residuals? Well, there is that word right here. It says residual. All I have to do is click this button that says plot, and there it goes. Here's what just happened. This line is my line of best fit. These new dots that just populated down here, and let me change their color so that it is easier to distinguish between the blue and the purple. I'll do red. Okay. Oh, and these still didn't show up, but these 4 points down here along the x-axis, this is the residual plot, okay? And it shares the same graph as my ordered pairs and my line of best fit. This residual graph shows me how far this ordered pair at x equals 1 is from the actual line of best fit. It is below it, so it's negative 1.895. You can also see that up here in this table. So the residual when, let's make this a little bigger. The residual when x equals 1 is negative 1.895. The residual when x equals 4 is positive 1.177. When it's 8, it's 1.94. And when it's 15, it's negative 1.22, okay? So my job is to select the largest residual. So here's where some students get tripped up. It does not matter if the residual is positive or negative. I am simply choosing the largest number. That largest number here is the 1.94. And don't forget about the actual question over here. It said which x value has the largest residual. So my x value is 8. And so that is the answer to number 2 is 8. And we got that same answer in the original video using the TI-84. Let's look at this right here. I had showed you by doing it by hand how to create a residual plot down here. So create a residual plot from this scatter plot below. And we did that together in the notes. Now you also could just take these ordered pairs and type them into your Desmos calculator and get a residual plot that way. Okay, let's come take a look at our EOC examples. The table below shows the number of hours that 7 students studied for a math test and the grade that each student earned on the test. How does Amanda's test score compare to the score predicted using the linear best fit model of data for a student who studied for 3.5 hours? So here's what we're going to do. We're going to clear everything out of our Desmos calculator. And then we're going to create a new table using the hours that they studied and what their test grade was. Now that I have all of these points typed into my table, let's again add the f of x expression. Okay, so here is all my information if I needed to know the line of best fit or the correlation coefficient. But what I'm really interested in right now is the residuals. So click on plot. And so let's come back here and take a look. We have all of our information right here in our table. And I'm going to try to make this a little bigger so that we can see it. And then let's come back over and look at these answer choice options. Amanda scored about 5 points lower than the score predicted. So let's look at Amanda. Amanda is the second one from the bottom. Okay, right here. That's Amanda. So did she score about 5 points lower? And the answer is no. Okay, negative 1.67 is what she scored lower. Let's look at option B. Amanda scored 5 points higher. That's not correct either. Amanda scored about 2 points lower. That is a negative 1.67. So because it's negative, it means that she did score lower. And 1.67 would round to 2. So my answer here is C. She scored about 2 points lower than the predicted student. Okay. Alrighty, let's do number 5 here. So we're going to do number 5. A survey was conducted to study the relationship between a student's height and their shoe size. The results of the survey are recorded below. What percent of students have shoe sizes that are more than one size different from the size predicted by the line of best fit? So here's what we're going to need to do. We are going to type in their height, their shoe size, and then we're going to just do this in Desmos. So let's reset everything here. I'm going to include a table. So 68. All right, so I went ahead and I just refreshed this page so that everything was blank and I could start brand new with a new table. So I went ahead and typed in this table. Again, I typed in this same equation, and now it is giving me all the information that I need to write the equation of the line and to discuss the correlation coefficient. But now what I really need is the residuals. So click plot residuals, and here's where they show up down here in red. So the original points are here, the residual plot is here. Okay? Now let's come back and look at what our question was. What percent of students have shoe sizes that are more than one size different? So more than one size means I'm looking for numbers greater than 1. So okay, so this is 1.59. So that's less than 1, less than 1. Remember, I'm ignoring the negative signs. Less than 1, oh, that's greater than 1. Less than 1, greater than 1, less than 1. So I counted 3 students or three people who had heights and shoe sizes greater than 1, 1.59, 1.91, and negative 1.08. Okay, so 3. And then in order to find the percentage, I need to do 3 divided by the total number of people, which is 8. And if I can just type that right in Desmos here. 3 divided by 8 is 0.375, which is option C. Option C, 37.5%. All right, and that's it, guys. We are going to wrap up this lesson so that you can do some more practice with residuals in your Desmos calculator.